So in this video we are going to record the mock exam A from the college board, and this is our question number 1. How many moles of ethane are in 5.3 gram of ethane? So we are going to apply a formula, that is mole is equal to mass by mr. So mass is 5.3, that has been given to us, and we have applied this formula. Mole is equal to mass by mr. So mr is this one, and moles comes out to be 1.8 times 10 to the power minus 1. So our answer is A. Next thing, which statement about ionization energy is true? So first of all, what is ionization energy? Ionization energy is basically the energy which is required by an atom to remove the valence electron from an isolated gaseous atom. As the energy is absorbed in ionization energy, so this is going to be endothermic because the energy is absorbed. And what is the way to write the ionization energy? The atom, which you can see in its gaseous form, an electron is removed from it, so an ion which is in gaseous form has been formed along with the loss of electron, you can see there. So C option is going to be the right one. It is the energy required to remove an electron from an atom or ion in the gaseous state, and is always endothermic. For the next question, which element has the most exothermic electron affinity? First, I am going to write the definition for electron affinity. So what we mean by electron affinity? Electron affinity is the energy change when 1 mole of electron is added to 1 mole of a neutral atom, forming 1 mole of negatively charged ion. So for example, this is an atom of, let's say it's going to be chlorine. Chlorine is having 7 electrons in its outermost shell. So when an electron has been added into it, so you can see the force of attraction has been developed there, and we can say that this is basically the electron affinity. So when force of attraction has been developed there, then energy is released. So that is going to be first electron affinity, and remember, first electron affinity, that is always going to be exothermic because a force of attraction is developed. But for second electron affinity, that is always going to be endothermic. Why endothermic? Because there is already been a force of attraction that has been developed, and it would be an ion. First of all, that would be an ion. So electron is also having a negative charge. Like for the second electron affinity, you can see one thing, it is going to have a negative charge. And when an electron has been added, there is a force of repulsion that is present between them. And when there is a force of repulsion, then you need to provide it energy so that this force of repulsion can be overcome. So first of all, this is the thing, second electron affinity is going to be endothermic. And then now electron affinity increase across the period. Why? Because of increase in nuclear charge, decrease in atomic radius, and electron affinity decrease across the group. So if you see the option which we have to see, that which is going to have most exothermic electron affinity, so the one which is going to be on the most right side, like we can see bromine, which belongs from group 7, this belongs from group 2, this belongs from group 1. So this is having the greatest electron affinity because it is present on the most right hand side of the periodic table and with the greatest nuclear charge, so it is going to have the greatest electron affinity. Then a compound contains a compound 39% sulfur, oxygen, and the remainder is hydrogen. What is the empirical formula of the compound? Empirical formula is the formula which shows us the simplest whole number ratio present between the atom of a compound. And if we want to find out like what is going to be the empirical formula. So I'm going to put sulfur like this, oxygen like this, and hydrogen like this. Sulfur is 39%, oxygen is 58.6, and in order to find for hydrogen, what you need to do, like total is 100% percentage for hydrogen, 100 minus 39 for sulfur minus 58.6, because remainder is hydrogen. So the answer comes out to be 2.4%. Now it is 2.4%. For sulfur you are going to divide with its atomic mass, that is 32. For oxygen it is going to be 16. For hydrogen it is going to be 1.008. This is 32.06. If you want to be more precise, 16.01. Now the answer comes out to be 1.22. It comes out to be 3.66. It comes out to be 2.40. Now we have to divide with the least value, that is 1.22, 1.22, and that is also 1.22. So the answer comes out to be 1:3, and that is going to be 2. So it is going to be SO3H2. Our answer is going to be C. So for the next question, they have given us the mass spectrum of element X, which is shown above. Which of the following is true? So first of all, if we want to consider the mass spectrum, the element which is going to have the tallest peak is going to be the one which is going to have most abundant isotope. This is basically representing isotope. This is isotope 1, 2 and 3, having atomic masses which is 70, 71 and 72. In first option they are saying element X is germanium. Germanium atomic mass is basically 72.6, which is even more than this, so it is not possible. X has a relative atomic mass which is between 71 and 72. It is not possible. Why? Because it should be between 70 to 72. And you can also see that 70 is having the tallest peak, so it should be between around 70 to 71, maybe you can say. In the C option, they are saying the most abundant isotope of X contain a total of 71 protons and neutrons. This is true because this is the one which is having the atomic mass which is equal to neutron plus proton. Atomic mass is equal to neutron plus proton. So option C is going to be the right one. So for the next question, they are saying when heated, anhydrous magnesium nitrate will decompose into magnesium oxide and a mixture of gases shown in the following equation. 1.48 gram of anhydrous magnesium nitrate is heated until no further reaction take place. What mass of nitrogen dioxide is produced? So first of all, we have the mass of magnesium nitrate. First we are going to find the mole of magnesium nitrate. That comes out to be mass by molar mass. Mass is 1.48, and if you calculate the molar mass of magnesium nitrate, that comes out to be 148.33, and that is equal to 0.01. They are saying the mass of nitrogen dioxide you need to find. So magnesium nitrate, I am going to put it on the left hand side, and for nitrogen dioxide I am going to put it on the right hand side. It comes out to be 2:4, and if you can see, if it is going to be 0.01, then that is going to be X, and by cross multiplying it, it comes out to be X is equal to 0.020. Then you have to find the mass. Mass is equal to mole times mR, and mole is how much? mole is 0.020, and for NO2 MR is going to be 46.01, that is for NO2, and the answer that comes out to be 0.92 grams, that is A. The diagram below are various model of metallic bonding, model A, model B, model C, model D. Which diagram represents the metallic bonding, pure metals? So if you see model D, in which you can see there are cations which are surrounded by delocalized electron, and there is a force of electrostatic force of attraction that is present between cation and delocalized electron. So model D is going to be the right diagram for metallic bonding. And what will be the other diagram for this? If you see model C is not for metals, that could be an alloy, because you can see there is an other element that has been put inside it. And this is also the alloy, because you can see although like they are arranged in a crystal lattice structure, but there is some smaller element which is present between the bigger element. And but model A, if you see model A, they are arranged in regular lattice type structure, and you can see it also represents the metallic bonding, they both are representing an alloy. So our answer is going to be A and D. Option is going to be D. The diagram below are various model of metallic bonding, which model represent a substitutional alloy such as brass. So first see what is going to be the substitutional alloy and what is going to be the interstitial alloy. So the difference between the substitutional alloy and the interstitial alloy, in substitutional alloy it is composed of different atoms with almost similar radii and does not affect the regular lattice structure. So if you see B option, that if you are having another element but it is not affecting the regular lattice structure, but if you, so this represents basically substitutional alloy, and if you see this option C, model C, then you are going to see that when another element enters into it, they disturb the normal regular lattice structure, and this represent interstitial alloy. So our answer for substitutional alloy is going to be model B. So for the next question, they are saying which model represent an alloy that is less malleable, harder, and has a higher melting point. So remember, interstitial alloy is the one which is going to be more harder. Why? Because when a force is applied, the layers would not slide past each other. You remember the condition for metals, that when a force is applied, the layers slide past each other, and that is a condition which makes them malleable and even ductile as well. But if you see option C, that is interstitial alloy, and when a force is applied, the layers would not slide past. So option C is going to be the right one. So for the next question, we are given with titanium bromide and having the charge of -2, we are having the ion. So first calculate their valence electron in order to draw their Lewis structure. So Ti is having how many electrons in the valence shell? It belongs from group 3, so having 3 electrons, and bromine is having 3. So bromine belongs from group 7, having 7 electrons, that would be multiplied with 3. and then you know there is a -2 charge on them as well, so I'm going to add 2 electrons because it means that they have gained electron. 3 plus 21 plus 2, that comes out to be 26. So Ti comes here, bromine comes here, other bromine comes here, and this bromine comes here as well. So first of all, I'm going to draw the valence like the bonding electrons, 1 2 3 4 5 6, then non-bonding electrons 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24. Now 2 electrons have been remaining, they would come at titanium here. Okay, now it is going to have -2 charge like this. So when we are going to find out its hybridization, that is going to be S for this bonding pair, sp for this bonding pair, sp2 for this bonding pair, and sp3 for the lone pair on titanium. So this is going to be sp3, okay, but sp3 is having 1 on 9.5, but due to the lone pair that is present on titanium, that would cause the repulsion of 2.5, so it comes out to be 107. And what is going to be its shape? Its shape is going to be, because of the presence of lone pair, its shape is going to be pyramidal. So answer is going to be B. For the next question, they are saying what is the strongest type of intermolecular force exhibited in the amino acid molecule serine. So you can see here there is a lone pair that is present there, and this lone pair would be attracted towards hydrogen having partial positive charge, and this one is oxygen lone pair partial negative charge, and this is hydrogen partial positive charge, and that is going to be hydrogen bonding. This strong type of force is basically called as hydrogen bonding, and that has been linked when oxygen has been connected with hydrogen and having lone pair on it and having a partial negative charge, and that would be attracted with hydrogen partial positive charge. So this bonding is going to be hydrogen bonding. So for the next question, they are saying the wavelength range of ultraviolet radiation is 10 to the power minus 8 meter. So this is basically wavelength, and the other one is having the wavelength infrared radiation is having 10 to the power minus 5 meter. So what we can see that the wavelength of infrared radiation is more than ultraviolet radiation. So this one is having greater wavelength. So we have a formula. Energy is equal to H, which is the Planck's constant, times V, which is the frequency, and V is equal to C by lambda, which is wavelength, and we can see V, which is frequency, is inversely proportional to wavelength. So now the one which is going to have lower wavelength is going to have higher frequency, and if it is going to have higher frequency, then as we know, energy is directly proportional to frequency. So if you are having higher frequency, then you are going to have more energy. So option C, if you see option C, that ultraviolet radiation which are having the lower wavelength, which is having the lower wavelength, that is having the higher frequency, and if its frequency is higher, then its energy is also higher. So option C is going to be the right one. So for question number 13, the diagram below shows the potential energy as two chlorine atoms approaches each other. So when two chlorine atoms approaches each other, first of all here the chlorine atoms are far apart from each other, that's why their potential energy is 0. But here when they make a bond, they are at optimum distance, like they are sharing electrons, so they are at optimum distance And because why the optimum distance? Because here we have two force of attraction, that is nucleus. One force is between nucleus and shared pair of electron, and the other force is going to be the repulsive force when these nucleus they come even more close together, that the repulsive force starts to occur, and that is going to be this force where they come even more close together like this. They come even more close together, so that the repulsive force here, repulsive force is going to be, repulsive force is between the same nucleus because they both are having positive charge. So the repulsive force is greater than the attractive force. Attractive force is basically between nucleus, which is positively charged, and shared pair of electron. And here at bottom, the attractive force between nucleus and shared pair of electron is greater than the repulsive force that is between two nucleus. So you can see in option C, the additional attractive force between two electrons and their opposite nuclei is greater than the repulsive force. That is why there is decrease in energy. That is why you are saying that the energy is decreasing. So our answer is going to be C. So in this question number 14, we have two containers. One is having 1 mole of nitrogen at 273. Other one is having 4 mole of nitrogen at 273. So we have greater number of moles in the second container. Which of the following statement is true? The pressure is greater in vessel 1. It is not possible because pressure is directly proportional to the number of moles. So number of moles in container 2 is high, so pressure should be greater in that one. So this option is going to be wrong. So now this option is wrong. So second option, the force at which molecules collide with the wall is greater in vessel 1 than pressure 2. So first of all, the force at which the molecules collide, that is dependent on the pressure. So greater the pressure, more will be the force. But in second container, pressure is greater, so this statement also become false. The pressure is same in each vessel. Pressure can't be same because pressure is directly proportional to the number of moles, and if number of moles are greater in second container, pressure should be more. Third option is saying the average kinetic energy of molecule is the same in both vessels. That is absolutely right, because kinetic energy is directly proportional to temperature, and if temperature are same, kinetic energy also needs to be same. So option D is going to be the right one. So for question number 15, they are saying CBr4 and CCl4, and this is having the very low vapor pressure, this is having very high vapor pressure. If you are having high vapor pressure, that means the force of attraction is going to be weaker. First of all, this is going to have less force of attraction. That's why it generally changes into vapor state very fast, and it is going to have strong force of attraction. Explain why CCl4 has a high vapor pressure than CBr4. If CCl4 has a high vapor pressure, that means it is going to have weaker force. First, it is going to have weaker force. So it might be this one or it might be this one. But now let's see whether it is going to form dipole force or London dispersion force. So this is Cl, 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 and this is going to be Cl. Like first of all, if I am going to draw, you can see like the dipole at opposite side, the resultant of this dipole is going to be this one. Okay, the resultant of this dipole and this dipole is going to be this one, and that cancel out the effect of each other, making the molecule non-polar, okay, that is non-polar, one thing, and so it is only having London dispersion force. London dispersion force, first of all, London dispersion force. So it is going to have the, you can say, weaker London dispersion force than CBr force. So our answer is going to be D, as it is a non-polar molecule. In this question, they are saying for the equilibrium equation shown which species are Bronsted-Lowry acid. So first of all, we can see this is an acid and this is going to be a base. So when acid lose a proton, then what it becomes, that is going to be a conjugate base. Conjugate base. And when this ammonia is gaining a proton, so it is becoming a conjugate acid. So from the equilibrium equation shown which species are Bronsted-Lowry acids, so your answer is going to be that is going to be D, because that is a pair which shows the Bronsted-Lowry acid, and this is also an acid. So which of the following species is a non-polar molecule containing polar bonds? So first of all, you can see we have these elements like carbon, carbon, hydrogen, hydrogen, hydrogen. So there is a less electronegativity difference between carbon and hydrogen. So first of all, it is a non-polar molecule and also having non-polar bonds. So it is a non-polar molecule, polar molecule, and also a non-polar bonds, because electronegativity difference is not much. Then I2, it's a non-polar molecules and also non-polar bonds. Non-polar with non-polar bond. Then if you see CCl4, carbon, chlorine, 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 chlorine. So if you see, the whole is a non-polar molecule, this is a non-polar molecule, but if you see bonds there, this is partial negative charge, partial positive charge, that makes a polar bond. So this is what they want, like this is a non-polar molecule with a polar bond. So that is going to be, C is going to be the right answer for us. For the next question, in a first order reaction, the half-life of the reactant is 30 minutes. How long it will take for the concentration of reactant to decrease to 12.5% to its initial value? So first of all, after 30 minutes, you know, half-life is when the concentration of reactant becomes half, so it becomes 50%, okay, and after again 30 minutes the concentration falls to half, which is 25%, and again after 30 minutes the concentration of reactant again falls to half, which is 12.5%. So total time taken is going to be 90 minutes. So our right answer is going to be B. Which of the following is an example of a physical change? So physical change is the one when the you can say the elements are not combined or are not changed into some other compounds. Okay, only the physical state can be changing, but not a chemical reaction occurs over there. So burning of wood is not, because after burning of wood you are forming carbon dioxide and water. Fermentation of grapes, you are forming ethanol and carbon dioxide, so it's also not the right one. Rusting of iron, you are forming Fe2O3, so a new compound is formed, so not. Melting of ice, the states remain same, like you are changing from only solid to liquid state and only physical changes have occurred, so our answer is going to be C. So for the next question, which statement below best describes our dynamic equilibrium? So there are certain conditions for dynamic equilibrium. First, it occurs in a closed system, and second, the rate of forward reaction is equal to rate of backward reaction. And the third thing we are going to see here is that the change in concentration of reactant and product is zero. So which option is going to be the right one? That is going to be the option C. The rate of forward reaction is equal to rate of reverse reaction in a closed system, and the concentration of reactant product is constant. Which of the following statement accounts for the difference in polarity of BF3 and NF3 molecule? So first of all, this is BF3. It's going to be a non-polar molecule as it is non-symmetrical. Like boron is surrounded by the same atoms, and also one thing, there is no lone pair present on it, which make it non-symmetrical. And if non-symmetrical, then we can say one thing here, that it is going to be non-polar. While if we see nitrogen, because of the presence of lone pair, it becomes symmetrical, and if it is symmetrical, it becomes polar. So because of the presence of lone pair on it, so lone pair creates the difference. So our answer is going to be the molecular geometry, because molecular geometry creates the difference for that. BF3 is going to be trigonal planar. That is going to be trigonal planar, and it makes it symmetrical, non-polar, and dipoles cancels out, while it makes it trigonal pyramidal, and dipole don't cancel out. So our answer is going to be D. So for the next question, we have indicator and their pKa value. Methyl orange 3.7, phenolphthalein 9.1, phenol red 7.9, bromothiol blue is 7.0. The pH range of 4 different indicators are given in the table. Which indicator would be suitable for titration involving HCl and ammonia? Ammonia is a weak base, while HCl is going to be the strong acid. And if you are talking about their equivalence point, then that is going to be when pH is smaller than 7, because it is a weak base. So equivalence point should fall below the 7 pH value. So if it is going to be the less than 7, then let's see the range. That is going to be methyl orange, because it has the pKa value which is less than 3.7. So that's going to be our right answer. Which element is reduced in the above reaction, and how does its oxidation number changes? So let's see chromium. Chromium is having the oxidation state of +3, and Cr2O7 minus 2S, Cr2O7 minus 2S. Chromium is having 2x, because there are 2 atoms. So if I have to find for chromium, I'm going to put x there, +7 times with -2, which is the oxidation state of oxygen, which is equal to -2. So 2x minus 14 equal to minus 2. 2x is equal to minus 2 plus 14, that becomes 12, and x comes out to be 6. Oxidation state of chromium is plus 6. They are saying which element is reduced. So chromium is reduced because its oxidation state changes from plus 6 to plus 3. So right answer is going to be B. So for the next question, a 100-gram block of copper at 85 degrees Celsius is placed into 200 gram of water at 25 degrees Celsius. The final temperature of the system is 28 degrees Celsius. Assuming no heat is lost to the surrounding, what is the specific heat capacity of copper? So first you need to find the heat transfer of water. Q is equal to mc delta T. M is the mass of water, which is 200 grams. C is the specific heat capacity of water, which is 4.18, times with the delta T, that comes out to be final temperature is like 28 and the water is 25. So final temperature minus initial temperature, and that comes out to be 2508. Now in order to find the heat capacity of copper, Q is equal to mc delta T, C is equal to Q divided by m delta T. So that is going to be the heat which has been generated by water. So that is 2508. And m is the mass of copper, that is going to be 100 grams, times with the delta T, like it is going to be 85 minus 28. Okay, 85 is the temperature of copper there, and the system temperature that falls to 28. So it is going to be like this, and the final answer comes out to be 0.44 joules per gram per Kelvin. So that is going to be B. The correct form of the solubility product of calcium phosphate, if we are going to dissolve calcium phosphate, it is going to form 3 calcium ions having plus 2 charge plus 2 phosphate ions PO4 minus 3. If we want to find the solubility product, only the products will be there, because that is solubility product. So calcium plus 2 having 3 here because there are 3 moles, times with phosphate PO4 minus 3, there will be 2 at the top. So our answer is going to be C. So the equilibrium reaction below has a equilibrium constant K is equal to 1.1. So we know if the value of K is greater than 1, then there will be more product. Product is more. So product is Y concentration of Y needs to be greater than that of X. So our answer is going to be D. Next question, which of the following describe the correct procedure to prepare 0.25 liter 0.1 molar Na2CO3 in aqueous form? Concentration is given, volume is given. Can we calculate the number of moles? Of course we can calculate. Moles is equal to concentration times volume, that is 0.25, and it comes out to be 0.025 mole. And from mole you have to calculate the mass. Mass is equal to mole times mR. Mole is 0.025, mR is 106, and it comes out to be 2.65. So what is the process to prepare this solution? This is the volumetric flask. You are going to add 2.65 grams of Na2CO3 in small amount of water, and then you are going to stir it. There is a calibration mark at the top, and that is 0.25 liter represents, and you are going to add the remaining water up to this mark, and that helps you to prepare the solution. So you are going to dissolve 2.65 gram of Na2CO3 in a small amount of distilled water and then dilute it to 0.25 liters. So our right answer is going to be B. In a titration, the equivalence point is reached when 23.70 milliliter of 0.02 molar potassium hydroxide reacts with 0.03 molar of sulfuric acid. What volume of acid is needed? So first of all, let's write the equation. H2SO4 is reacting in aqueous form, is reacting with 2 moles of KOH in aqueous form, and then it is going to form K2SO4 in aqueous form plus 2 water molecules in liquid form. You need to see one thing: acid and base, they are going to have 1:2. There is a formula: concentration of acid times volume of acid is equal to concentration of base times volume of base. But as you know, 1 mole of acid is reacting with 2 mole of base, so you have to divide that by 2. And when you have to find the volume of acid, concentration of base, volume of base divided by 2 times volume time concentration of acid. So now let's putting the value. Concentration of base is going to be 0.02 and volume of base is 23.70. We are going to keep it in milliliter. 2 times the concentration of acid is 0.03. Answer comes out to be 7.9 milliliter. That is A. Which of the following not a correct representation of hydrogen bonding? That is going to be A, because for hydrogen bonding, this hydrogen, if it wants to make a hydrogen bonding, so one hydrogen here, one hydrogen can't form hydrogen bonding with another hydrogen, so that's why it is wrong. So our answer is A, because this can also make, because it can also attach with hydrogen partial positive charge, with oxygen like this, partial negative charge with another hydrogen like this, and it has made the hydrogen bonding correctly, and this hydrogen bonding is also correct. So for the question number 30, they are saying 2CO2 is forming 2CO in gas form plus O2. Kc is equal to 31.2. So first of all, they have given us different concentration, and they are saying where the equilibrium will move. First, I'm going to find the value of Q. Q is equal to the product, which is CO square O2 over, we have CO2, and that would be square as well. Putting the values there, 2.0 times 10 to the power minus 3 whole square, and for O2 is going to be 0.010, and at bottom is going to be carbon dioxide, that is 2.0 times 10 to the power minus 3, and the answer that comes out to be is Q is equal to square, that is 0.5625. Q is smaller than Kc. If Q is smaller than Kc, then equilibrium has to move to the right to reach the equilibrium. So here basically two options are correct. Option C is also correct and option A is also correct. 31. As a sample of KNO3 is stirred into water at 25 degrees Celsius, the compound dissolves endothermically. So, which of the following best helps to explain why the process is thermodynamically favorable at 25 degrees Celsius. So when you are dissolving KNO3 from solid, it is going to change into K positive in aqueous form and NO3 minus in aqueous form. So you are going from solid to aqueous form, so entropy increases. Entropy increases and delta G is equal to delta H minus T delta S. So delta H is endothermic, so it's going to be positive. And as you can see, you are going from solid to liquid state, okay, when it is dissolved in water, so entropy becomes positive, and then minus T delta S, that becomes negative. So entropy is positive, that tells you when you are trying to dissolve from solid to liquid state and entropy increases, so this whole terms becomes negative, delta G becomes negative. So dissolving the salt increase the entropy of the system. This is going to be the thing that tells us why the process is thermodynamically favorable at 25 degrees Celsius. The following equation shows a reaction between the mineral rutile TiO2 and carbon. So we have the equation TiO2 in solid state plus 2 carbon in solid state, and they are forming titanium in solid state plus 2 carbon monoxide in gas form. So we need to find enthalpy of reaction here, and here I am going to put the elements: titanium in solid state plus oxygen in gas form plus carbon in solid state, and we have enthalpy of formation for TiO2. So I am going to put arrow from here to there. It is going to be minus 890. And then for carbon monoxide, I have to move from this point to this point, but here I am going to multiply 2 with minus 110.5, and I have to find out enthalpy of reaction. So how I am going to do it? Like, this is going to be the starting point and this is going to be the ending point. So one arrow will go from this point to this point, and one arrow will go from this point to this point. So this is root 1 and this is root 2. So root 1 is minus 890 plus enthalpy of reaction is equal to 2 times minus 110.5. So enthalpy of reaction after solving them comes out to be plus 669.0 kilojoules per mole. Answer is A. For the next question, they are giving us certain acids X, Y and Z. pH is 2.1 and its concentration is the lowest, so definitely it is going to be the strongest acid because its pH is lowest, and the one which is having the lowest pH is going to be the strongest acid. Then this is considered to be the pH is the highest and concentration is also the highest, that is considered to be the weakest one. And this is going to comes in the medium where the pH is 3.0 and the concentration is 1.5. Concentration is low as well. So this is the way we can say X is the strongest, and then we have Y, and then we have Z. So this is going to be A. So the next question, 2CH3CHO is forming this as a product. The proposed mechanism for the reaction of ethanol in dilute alkaline solution to form 3-hydroxybutanol is shown. First is a slow step. This is a slow step, that means it is a rate determining step. Rate determining step first of all. and its rate is going to be equal to K times CH3 CHO and OH minus. And then we can also analyze one thing, that OH is reacting in the first reaction and also regenerated at the last reaction as well. So we can say that OH minus is going to be the catalyst. Okay, so which option is not correct? The option that is not correct is going to be A. Why? Because rate is written like this, but there is no K value here, so this option is wrong. Option B is correct. Rate step 1 is the rate determining step, the slowest step. OH minus is a catalyst, and 2 and 3 have lower activation energy than step 1. Of course, the one which is having the slow step is going to have the highest activation energy. What is activation energy? The energy required to start a reaction. For the next question, they are asking which two species are correctly identified as Bronsted-Lowry acid in the reaction. This is acid, this is going to be the base, and when acid lose a proton, it becomes its conjugate base. And you know, this is base when it accepts proton, so it becomes its conjugate acid. So our answer is going to be H3NSO3 minus and NH4 positive. So that is going to be D. So for the next question, they are saying which of the following statement explains why gases are highly compressible compared to solid and liquids. So first of all, why gases are compressible? Because if you see the structure of gases, then gases particles are widespread, okay, and the particles have a lot of space between them. So that is why if you apply pressure on them, the gas particles would come closer. So option C is going to be the right one, that gases are highly compressible because the particles are widely spread, leaving large amount of empty spaces between them. 37th question. If you see 37th question, then you are going to see that these are anions and the positive is going to be cations, and this must be an ionic compound because ionic compound are formed by the electrostatic force of attraction between cations and anions. So ionic compound are soluble in water because water is polar, soluble in water as it is polar. And what happens? They don't conduct electricity in solid state. Do not conduct. What is the reason why they do not conduct electricity in solid state? Because they don't have free moving ions. No free moving ions. While if you see like if they are dissolved in water, like in aqueous form, so they conduct electricity, and they also conduct electricity in molten form. In molten form they also conduct electricity. So they also conduct electricity in molten form as well. So which option is going to be the right one? Option A is going to be the right one because they are saying it is brittle, water soluble electrolyte with poor conductivity and thermal conductivity as a solid, because in solid they don't have free moving ions. So that's why they don't conduct electricity in solid form. So option A is going to be the right one. So for the next question, a gas mixture at equilibrium held over water at 35 degrees Celsius contains 3 moles of helium, 5 moles of argon and 2 moles of water vapors. So the total number of moles are 3 plus 5 plus 2, and that comes out to be 10. If the total pressure is 740 millimeter mercury, what is the vapor pressure of water? So for water, what you need to do, you are going to do like partial pressure of water vapors is going to be equal to n water molecules divided by total number of molecules times with the total pressure. So n water molecules are 2 divided by 10 times with the total pressure, that is 740, and that comes out to be 148 millimeter of mercury. So our answer is C. So the next question, the difference between a galvanic cell and an electrolytic cell. First let me write the characteristics of galvanic and electrolytic cell. So the difference between electrolytic cell and galvanic cell, that electrolytic cell that requires external source, while the reaction is non-spontaneous, that means it doesn't take place on its own, it requires an external electricity source. And electron flow from anode to cathode, but for galvanic cell it requires no external source and generates electricity from a spontaneous reaction, and electron here also flow from anode to cathode. So our answer is going to be C, that a galvanic cell produces electrical energy from a spontaneous reaction, while an electrolytic cell requires electrical energy to drive a non-spontaneous reaction. Determine the amount of energy in joules that a carbon dioxide molecules gain when it absorbs a photon of infrared radiation of wavelength 7 times 10 to the power minus 7. So we have a formula, energy is equal to Planck's constant times frequency, and frequency is equal to C over lambda, which is wavelength. H is 6.6 times 10 to the power minus 34, and C is 3 times 10 to the power 8, while wavelength is going to be 7 times 10 to the power minus 7, and the answer that comes out to be is 2.84 times 10 to the power minus 19 joules. So our answer is going to be D. A sample of bromine and nitrogen gas in a closed container of constant volume is closed until its absolute temperature is halved. Which of the following statement is true? We know one thing, that pressure is directly proportional to temperature. So if temperature is halved, the pressure also needs to be halved. So option C is going to be the right one. So for question number 42, they are saying C2H5OH plus 3O2, they are forming 2CO2 plus 3 water molecules. So we have to find out enthalpy of formation of ethanol. We are going to use Hess law, C2H5OH plus oxygen, and it is forming 2CO2 plus 3 water molecules. So enthalpy of combustion for this ethanol, they have given us minus 1367, that has been given to us. We are going to put carbon, hydrogen and oxygen at the bottom. We need to find enthalpy of formation for ethanol. If we want to find it for ethanol, we are going to put the arrow from it, and enthalpy of formation for ethanol we need to find out. For carbon dioxide, as you know, for carbon dioxide we need 2 mole of carbon. We need 2 mole of carbon. For 1 mole of carbon, that is minus 394, and for 2 mole of carbon, that is going to be 2 times minus 394. For hydrogen, 1 mole of hydrogen is having minus 286. For 3 mole of hydrogen, that is having how much? That is having 3 times minus 286. So this is going to be starting point, this is going to be ending point. Root 1 is from this point to this point, that is root 1. Let me choose another color. This is root 1 and this is going to be root 2. So then what happens, we are going to take root 1 is equal to root 2. Root 1 is going to be 2 times minus 394 plus 3 times minus 286 is equal to root 2, which is enthalpy of formation plus minus 1367. And enthalpy of formation after calculating comes out to be minus 279 kilojoules per mole. So our answer is B. Ammonium chloride dissolves endothermically. When ammonium chloride dissolves, ammonium chloride is in solid state. It is going to be dissolved and form ammonium ion in aqueous form plus chloride ion in aqueous form. So you are going from solid state to aqueous form. That means when there is a bond between ammonium and chloride, when it breaks, it is absorbing energy, and that is heat energy. And heat energy, when it absorbed, that is basically the kinetic energy, because heat is a sum of molecular kinetic energy. Heat is a sum of molecular kinetic energy. And when heat energy, when they are dissolved, they are going to develop the force of attraction with water, and that would change into the chemical energy. So basically kinetic energy is changing into chemical energy. So option B is correct. So question number 44, the table shows list of a pair of elements and their relative first ionization energy. Which pair correctly identifies the correct relative ionization energy? So we have lower first ionization energy and higher first ionization energy. When we see oxygen and nitrogen, so oxygen has 8 electrons, 1s2, 2s2, and then we have 2p4. And for nitrogen, 7 elements, 1s2, 2s2, 2p3. If we see 2p4, it is going to be like this, like 2px, 2py, 2pz, 2px, 2py, 2pz. So we have electrons like this, like this, like this, and for nitrogen we have electron like this. Because of the repulsion in 2px, there is a repulsion between electrons in 2px. That is why oxygen has lower ionization energy as compared to nitrogen. So option C is going to be the right one. Also, we need to remember this thing, that ionization energy increase across period and it decrease across group. So if we apply this technique on everything, C comes out to be the right thing. So for this question number 45, the weak acid CH3COH has a pK of 4.76. A solution is prepared by mixing these both like a volume of 0.2 molar CH3COH and 0.8 gram of NaOH. So first let's find out the mole of NaOH. Mole of NaOH is mass over molar mass, 8 divided by, we have molar mass of how much? We have 39.998. It comes out to be 0.02 mole. Okay, And then for mole of CH3COH, what we need to do, concentration times volume 0.2 times 0.25, and that comes out to be 0.05. Okay, now we need to use the ice table for this thing, and before going into that, we have a formula. pH is equal to pKa plus log of 10 concentration of salt divided by concentration of acid. And we know one thing here, pK is 4.76. But for concentration of salt, the formula is mole of salt divided by volume. Volume is the same for the salt as well as for the acid. So mole of acid is there divided by volume. So volume is same, so we can cancel out the volumes and we just only need to consider the moles. Now we are going to use the ICE method for that. ICE method is ICE, initial change equilibrium, and this is CH3COOH, this is OH minus, and this is CH3COO minus. Initial CH3COOH is how much? 0.05 moles we have calculated here, and for OH minus is 0.02, and this is going to be 0 initially. But what happens, as they are combined, they have 1:1, so this is going to be change is going to be minus 0.02 because this is 1 ratio and it is a limiting reactant. This is also minus 0.02 and this is plus 0.02. okay, so at equilibrium it is going to be 0.03, which is acid, and this is going to be 0.02, and this becomes cancel out. So now applying pH is equal to pKa plus log of 10 concentration of mole of salt at top, and at bottom we have mole of acid. So what is going to happen? pK is how much? 4.76 plus log of 10. Mole of salt is how much we have found? That is 0.02. And for acid we have what? 0.03. After finding it, we are going to have the formula for A, value is going to be 4.58. Answer is C. So for the next question, the pH of a sample of acid rain at 25 degrees Celsius is 4.55. What is the hydroxide ion concentration in the sample? So first of all, we have the formula pH plus POH, which is equal to 14. And if we want to find out the value of POH, that comes out to be 14 minus pH value is 4.55. And it comes out to be 9.45, and hydroxide ion concentration is going to be equal to 10 to the power minus POH. 10 to the power minus POH is minus 9.45 is equal to, you have to put it in calculator, it comes out to be 3.55 times 10 to the power minus 10, and that is B. So for the question number 47, the Maxwell-Boltzmann distribution of the distribution of molecular energies in sample 1 of a gas is shown. A change was made to the reaction condition as shown by the dotted curve labeled sample 2. With what factors was changed in the reaction condition to produce the dotted curve labeled sample 2? So they are saying it was sample 1, but what are the conditions that they have done when it comes out to be less curve? And as it is the less curve, that means the successful collisions is reduced. Collisions is reduced, like the molecules having the successful collisions, molecules having successful collisions are reduced. Successful collisions are reduced. So how we can achieve it? First of all, they have given us certain option, like in the A option they are saying volume is reduced. If volume is reduced, then pressure is increased, because pressure and volume, they are inversely proportional. So when volume is reduced, pressure is increased. If pressure is increased, then there needs to be have more successful collisions. More successful collisions if pressure is increased. But this graph, the dotted line graph, is at the bottom. That means now we are having the less number of molecules having successful collisions. So this option is going to be false. Let's see option C. If temperature is increased, like if temperature is increased, then the graph needs to be you can say the graph need temperature increase cause the curve shift down and to the right hand side. Why? Because now molecules would be having greater energies. Okay, as we know, temperature is directly proportional to kinetic energy. Now there should be more molecules having successful collision, so the graph must need to move towards right side. Okay, then afterwards they are saying catalyst is added. If catalyst is added, then we are going to have more molecules, like we are going to have more molecules have energy greater than activation energy. So with the activation energy, so option, that one is going to be the right one, is going to be option B, because there will be nothing like temperature increase has no effect, catalyst added has no effect, and volume reduce has no effect on this shape of the graph when we have lesser molecules which are having less successful collisions. So option B is going to be the right one. Question number 48 says, which of the following statement about the integrated rate law for a first order reaction is true? So for first order reaction, the integrated equation is ln A, concentration of A is equal to minus kT plus ln of initial concentration. And when I'm going to plot a graph of ln A versus time, like when we are going to plot, so when the graph is plotted versus ln A versus time, okay, because y is equal to mx plus c, then the slope that comes out to be, we are going to have a straight line, and the slope is going to be minus k. Okay, and if the slope is going to be minus k, then what is going to be the right answer for that? The slope of ln A versus time plot is equal to rate constant. That is going to be equal to rate constant. So our answer is going to be C. The distance that an amino acid moves on chromatograph depends on size of amino acid. First of all, if size is smaller, it would travel more further. It would also travel on the polarity of amino acid. If it is going to be more polar, then it's going to travel more further. So the other thing it is going to be dependent on is going to be the solubility of amino acid in mobile phase. Mobile phase is the one which is traveling upward. And also it is dependent on the solubility of amino acid, like amino acid in stationary phase as well, because if it is more soluble in stationary phase, it will not travel further. So answer is going to be B. the intermolecular force between amino acid and both the mobile and stationary phase. So for the next question, nitrogen gas reacts with hydrogen gas to produce ammonia. If 6 mole of hydrogen gas reacts with excess nitrogen gas, how many moles of ammonia are produced? So first of all, they want us to find out ammonia. So ammonia is this, and this is going to be hydrogen H2. We have 3:2. If we have 6 moles there, this is going to be X, and X comes out to be 12/3, and that is going to be 4 moles. So answer is B. So for the next question, now they are saying which of the following statement is true? First option, H2O is shown acting as a Bronsted-Lowry acid only. But if you see option B, H2O here is accepting a proton from nitric acid, so H2O is acting as a base there. So option A is going to be incorrect. NO3 minus is a strong base. If you see NO3 minus, then you are going to see, like, as HNO3 is an acid, a strong acid, water is a base, so it is going to form a conjugate base, which is going to be a weak base. Conjugate base is weak base there, weak base. So this is not going to be the strong base. Option B is incorrect. H2 acts as a Bronsted-Lowry acid twice. Here H2 is donating a proton, so it is acting as an acid. It's correct. And if you see option, this one, fourth option, then H2O is basically donating a proton to ammonia, so it is also acting as an acid. So H2 acts as a Bronsted-Lowry acid twice. Option C is going to be the right one. So for the next question, nickel ions are gaining 2 electrons that are forming nickel solid, and that is having more negative electrons, so that is basically acting as an anode, and this is acting as a cathode. And you know that we have a formula, E naught of cell is equal to E naught of cathode minus anode. So cathode is plus 1.50 minus 0.25, that comes out to be 1.75. Our answer can be A or B. Now for delta G, we have to use this formula, minus N Fe, and when we are going to apply that formula, minus N, and for N we need to first balance the equation. You know, anode NiS is forming Ni plus 2, because loss of electron we are going to write on the right hand side, and the gain of electron we are going to write on the left hand side. Plus 3 electrons, and is going to be, now this is going to multiply it with 3 in order to balance the electron. This is going to be multiplied with 2, so this one would become nickel solid. We have 3 nickel solid, and that's going to form 3 nickel ions plus 6 electrons, and we are going to have 2 Au plus 3 plus 6 electrons, and that is going to form 2 Au solid. So we have how many electrons after balancing? 6 electrons. So 6 I am going to put here. For Faraday's constant is 96,500. For E naught of the cell is minus 1.75, and the answer will come out to be in joules. That is minus 1013,000 joules. And when you are going to convert it into kilojoules, so divide by 1000, minus 1013 kilojoules per mole. So our answer is B. So for the next question, equal volume of solution in 2 different vessels are represented above. Water molecules are not shown. If we count the positive ions here, positive ions are how much? They are 8, because they are positive ions. and negative ions, if you see, is going to be 16. So that is going to have positive and negative ions are 1:2 there, so that must need to be calcium chloride first of all. And if you see positive ion here, that is going to be 4, and negative ion here, that is going to be 4 as well. That needs to be 1:1, so that could be KCl. Now, if you see positive ions are here 4 and negative positive ions are here 4. So if you move from this to this, you can see that it is going to be half the molarity. Half the molarity. So our right answer is going to be D, KCl with half the molarity of the solution in vessel 1. Now for the next question, which species are arranged in order of increasing entropy? Entropy means disorderness of the system, orderness of system. So in gas particles we have like the greatest entropy because of the greatest disorderness of the system, then is liquid, then is solids. So gas, if you see, we have this gas, then liquid, then solid, then you can see we have of increasing entropy we have two options. Increasing entropy means like we need to choose the increasing part, like the most largest entropy on the right hand side. So it is having the most largest entropy on the gas state, which is on the right side. And then we have two options, like first we have liquid here and we have liquid here as well. So you can see the one which is having you can say the smaller molecule would be having more entropy. So our right answer is going to be C, because Hg is going to be the smaller molecule having more entropy than C2H5OH, which is again going to have more entropy than magnesium in solid state. So right answer is going to be C. So for the next question, question number 55, which of the following compound does not form hydrogen bond? So this is the structure of NH3, which can form hydrogen bond. This is OH, it can also form hydrogen bond. Like C part can also form. So can't be, and CH2 NH2, that can also form hydrogen bond as well. But only this option, if you see option B, that is not able to form hydrogen bond because fluorine is not linked with hydrogen. So option B is going to be the right one. For 56, what can be deduced about the value of Kp here? So Kp is going to be, AB is how many? AB is 1, 2, 3, 4. AB is 4 there, and A2 and B2 is 1, 1. Kp is going to be equal to AB whole square divided by A2 and B2. Okay, let's just do this. So 4 square is over we can do 4 square over A2 B2 1 time 1, so that's 16, and you can see that Kp is going to be greater than 1, so our answer is going to be C there. So the next question, they are saying which of the following comparison of chemical and physical processes is the most accurate. So first of all, when an atoms they make bonds, this force of attraction that is present, like when they are making a shear pair of electron, that is basically intramolecular force of attraction. Intramolecular force of attraction. So what happens when atoms, like when they form bonds, so this is going to be intramolecular force of attraction that is going to be formed. So when an atom, they are going to have chemical change, so that they are going to have intramolecular force of attraction. When an atoms make bond, a chemical change occurs and intramolecular force of attraction develops. But when a physical change, like for example, you are converting iodine from solid state to iodine in liquid form, then what happens? Intermolecular force of attraction breaks. Intermolecular force of attraction here is going to be van der Waals force that is going to break. Attraction breaks. Then what is going to be our answer? Our answer is going to be chemical forces are characterized by intramolecular force, while physical properties are characterized by changes only in intermolecular force. Our answer is going to be C. So how many lone pairs of electron exist on I3 minus molecules? So first we need to find the valence electron of iodine. It belongs from group 7. So it has 7 electrons. So 7 times 3 plus 1. Why plus 1? Because there is a negative charge, which means that it has gained electrons. So it becomes 22. When we are going to draw the structure of iodine and here iodine, so you can see we have like one bond pair here, one bond pair here. So the remaining is going to be the lone pair. How can we find the lone pairs here? 22 minus, we have 4 bond pairs, which becomes equal to 18. We have 4 bond pairs, 1 2 3 4, and then divide it by 2. That means we are going to have 9 lone pairs. And 9 lone pairs, how they are going to arrange? 1 2 3 4 6, 1 2 3 4 5 6. So they are 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So there will be 6 more electrons which would come as lone pair here, lone pair here, and lone pair here. So how many lone pairs will become? Like, just first I will draw the bond pairs like this, and there are how many lone pairs? There will be 9 lone pairs. Now for the next question, they are saying that which factor increase the entropy of the system? So if we see statement 1, increasing the temperature without changing the volume of container. Increasing the temperature means, like as we know, kinetic energy is directly proportional to temperature. So increasing the temperature increase the kinetic energy of the particles, and faster moving particles will be more disordered. Particles will be more disordered. That means if they are going to be more disordered, that they are going to have more entropy. So option 1 is correct. Decreasing the concentration of gas without changing the volume of container. So if you are decreasing the concentration, and that cause equilibrium to shift towards right hand side, because you are decreasing its concentration, and equilibrium shift towards right hand side. So if right hand side it moves, then that means that there are going to be greater number of moles produced to minimize the change, and you are going to have more carbon dioxide that would be produced. And what happened? Disorderness. If more particles are there, more particles of carbon dioxide are there, because you are removing carbon dioxide, and equilibrium move towards right hand side. So if more particles are there, that means there will be more disorderness. And for the third option, increasing the pressure without changing the volume of container. So by increasing the pressure, there will be decrease in the volume, and equilibrium will shift towards the fewer number of molecules. So that would make us to shift towards left hand side. So increasing the pressure pressure is inversely proportional to volume, so the equilibrium will shift towards left hand side so that would basically decrease the entropy. So option 1 and option 2 would result in increasing entropy, and that would result in decreasing entropy, because equilibrium move towards left hand side and you are going to have solid there. So option A is going to be the correct one. So for the next question, a sealed container with a volume of 2.0 liter contains 2 atm of N2O4 at a constant temperature 350 Kelvin. The gas decomposes according to the reaction. The partial pressure of 2NO2 over time are recorded in the table below. Based on the data, what claims can be made about the system? So first of all, we must know one thing, that equilibrium is reached when the pressure remains constant. And when pressure remains constant, equilibrium is reached. And what does it indicates? That rate of forward reaction is equal to rate of backward reaction. Then afterwards we are going to see one thing, that from the table, if you see between 80 and 100, you are going to see that partial pressure that becomes constant. So between 80 to 100 we can see partial pressure becomes constant. And what can be deduced? Like option B is going to be the right one, because equilibrium is reached after 80 seconds, because pressure of both gases that remains constant.